Okay, class, today we're going to look at like terms in the distributive property. The first thing we want to look at is a term. It's a number, a variable, or the product of a number and one or more variables. Some examples of some terms are right here in this expression here. 6a squared minus 5ab plus 3b minus 12. Those are four different terms that make up that expression. So a term is just going to be a number, or a variable, or both put together. A constant is a term that has no variable. So our 12 here is a constant. There's no variable that goes with it. So those are just your numbers. Okay. And then in green here we have our coefficients. Those are numerical factors of a term. So with each term, there's a number that is associated with that term. For this one, it's 6. For this one right here, it's 5 and 3 and 12. Those are our coefficients to each of those terms. Okay, so those are our coefficients. Now, we can talk about terms that are like. And what I mean by like terms is that they have exactly the same variable factors. Looking at our like terms here, column, look at these right down here, we have a 3x and negative 2x. They each have an x in their terms, so they're alike. Then the next one, they both have x squared, and then they have an xy, and then they have x squared y cubed. So these are all like terms. These terms can be added together or subtracted from each other. Non-like terms you cannot add or subtract. So 8x and 7y, we could not add those. Or 5y and 7y squared. Those are not alike because they do not have the same variables in them. So let's look at how we combine like terms. So we're going to look at example 1. It says combining like terms. Just erase these marks here. So, looking at letter A, we have 3x squared plus 5x squared. In order to add like terms, we look at the coefficients. We look at the 3 and 5. These are the coefficients, and we add those two numbers together. 3 and 5 add to get 8. So we get an 8, and then we just put the x squared next to it. And that is how we combine like terms. If they're alike, we can only do that again if they are alike. The letter B, we have negative c plus c. Now, the c does not have a coefficient or a number before it. When you see that, there's actually a 1 before it. So there's actually a 1 there. We just don't write very many 1s in algebra. 1s are just kind of implied. If there's nothing in front of a variable, it's implied that it is a 1. So we have negative 5c plus 1c. So we take negative 5 plus 1. They have different signs. So if you remember, we subtract, which is a 4, and then you take the sign of the bigger number, so that's negative. So we get negative 1c, and we don't even have to write the negative 1. This is the same as saying negative c. All right, letter C, we have 7y and 6y. We take 7 and 6, add those together. We get 13, we get 13y. Next one, we have 3t minus t. So if we take 3t minus t, remember there's a 1 in front of that t, so we have 3t minus t gives you 2t. 3 minus 1 gives you 2. And that is how you combine like terms. You just have to make sure that they are, in fact, alike. And the next thing we're going to look at is the distributive property. Distributive property, if you look at some examples here, that's if we take a number, what we'll call A, and we have it being multiplied by the sum of B plus C. We can take A and multiply it by each thing inside of the parentheses, like AB and AC. That's the same expression. So those are equivalent expressions, but when we separate it out, when we take the A and multiply it by the B and multiply it by the C, that's called the distributive property. And you can see there's various ways for that to happen. The next one over here, the A is on the right side, but you still do the exact same thing. You can take the B and multiply it by the A, C and multiply it by the A. And it also works when you have a minus in there as well. And then you can see some examples. This first one here, 5 times x plus 6, that turns into 5x, 5 times x. Okay. So we do an arrow, 5 times x, and then 5 times 6. So 5 times 6. And that works for all of these cases. It even works when you've got a minus sign. 9 times x minus 9 times 2. So this is the distributive property. We're going to work a few examples of the distributive property. Get it over to that next page. All right, so let's look at letter A. In example 2, we have 7 times y plus 4. It helps to draw arrows on these. That wasn't my problem. I'm sorry about that. Just 1 second. There it is. Okay, so if we take an arrow from 7, we draw it to the y and to the 4. We take 7 times y, and then 7 times positive 4. So we get 7 times y is just 7y. When you multiply a number times its variable, you just write them next to each other. And then we have plus 7 times 4. 7 times 4, we get 28. And that is the simplified version. So you do need to go ahead and multiply anything that you can, like we did with the 7 times the 4. All right, letter B. On letter B, we have negative 8x times x plus 5. So we're going to take the negative 8 and we're going to multiply it by the x and by the 5. All right, now when the number out front is negative like our 8 is, you need to be careful with that. With these, you have to be very careful with the sign. So we have negative 8 times x, and then we have negative 8 again, and we're going to multiply it by the 5. So then we have negative 8x minus 40. We have negative 8x minus 40. All right, let's look at the next one. The next one, we have 4, and then parentheses times x minus 5. So we're going to take the 4 and we're going to multiply it by each of those. So we have 4 times x, and then you need to be sure that you always put a sign right here. And if you look at the 4, because we're taking a positive 4 and multiplying it by the x and the negative 5. So I want to put a positive 4. Think of this, remember there's a positive. When it's not written, it's always assumed positive. So we're going to put a plus 4 because we need to have some type of sign here, okay? And then we're going to multiply that by a negative 5. Think of this right here as more like a negative to the 5 as opposed to a minus sign. It serves both cases. Okay, so it works for both. All right, so then we have 4x, and then we have a positive 4 times a negative 5, that gives us negative 20. So whatever, the sign here is going to be whatever it is out front. So looking at the next one, we're going to see that it is negative 5. So that there's going to be a negative in between. So we have negative 5 times 2z. Okay. And then we're going to pair negative 5 times 7. So again, the sign here is determined by this right here. It's the easiest way to do it. So we have a negative 5 times a 7. Okay. Now we go through and simplify. We get negative 10z minus 35. So it's no different if we have a number before the variable. We just multiply that by that negative 5 and we get the negative 10. Right, now we're going to just practice putting all this together. putting this all together. We're going to do the distributive property twice in one problem, and then we're going to do like we did on that first example and combine any like terms that we have. So if you look at example A, we have 2 times x minus 5 plus 3 times x plus 5. So we're going to do this twice is what we're going to do, okay? Always keeping in mind what our sign is with that number out front. It's a positive, so that's what's going to go in the middle. All right, so we have 2x times, or I'm sorry, let's skip ahead. 2 times x, which is just going to be 2x, all right? And then we have plus 2 times a negative 5. Be sure you take this sign with that 5, okay? Take the sign, whatever it is, before it. And then we're going to do the same thing with the 3. All right, so we have plus 3x, and then plus is right here, so that's what's going to go here, plus 3 times 5. So that gives us 2x, and we're just going to go through and multiply everything. We've got 2x, and we have 2 times a negative 5, that gives you negative 10, plus 3x, plus 3 times 5, which is 15. Okay. Once we get to this point, we can combine our like terms. Okay, so what I'm going to do is I'm going to underline some like terms. We have a 2x and a 3x. Those are alike because they have the same variable term. Then we have our number terms, negative 10 and 15. Okay, so now we can go through and combine those. So we have a 2x and a 3x. That gives us a 5x. And then we have negative 10 plus 15. That gives us a plus 5 because they're different signs. So we take their difference. We get 5x plus 5. Okay, let's move on to letter B. All right, letter B, we have negative y, or negative times y minus 6. Now let me tell you something about this negative right here. This is actually negative 1 in front of that. But again, like I said with ones, we don't always write ones in algebra. So there's actually a 1 there. So what we're going to be doing is we're going to be taking negative 1, and we're going to be multiplying it by the y and by the negative 6. So we have negative 1 times y. And then again, keep in mind that sign is negative. So we put a minus here, a minus 1 times a negative 6. Okay, so in this case, both of these signs were negative, okay, because the sign was negative on both. And then we'll do the same thing to negative 3. We take the negative 3 and multiply it by the first number, 2y, the first term. And then we take negative 3 again, and we multiply it by negative 1. So this one is one where you really got to be careful with the signs. So we have negative y, negative 1 times negative 6, and don't write the next sign until you know what it's going to be. So this is negative times negative, it's going to be positive. 1 times 6 is 6. And then we have negative 3 times 2y. That's negative 3 times positive 2 is negative 6y. Negative 3 times negative 1 is positive 3. And then we just go through and combine our like terms. We have negative y and negative 6y. There's a 1 there that you don't see. So we add those, we get negative 7y. Plus 6 plus 3 is 9, so plus 9. And I'll give you just a second to write that down. Guys, this was probably the hardest lesson we've had so far this year, so if there was any questions, please be sure to ask me during our next class. Thank you for watching.